Hi, welcome to the second week of Chapter 2. This week we're going to talk about software. Software is probably as widespread as anything else that this industry has, and we're going to quickly brush through a lot of different areas of software. So hold on and let's go through it. So software consists of computer programs that actually operate the hardware. Can be divided into two areas, both system software and application. System software, operating systems, utilities, middleware, application software, stuff that users use, and you're familiar with it because you're watching one right now on PowerPoint and on YouTube videos. Now, sphere of influence, boys, what kind of problems and opportunities are we trying to solve? Is it a personal need for a personal sphere of influence? Is it a productivity software, Excel, things to help you be more effective, a calendar? Usually you'll see from an intersection, you get, if it's a work group, it's two or more people. It just kind of helps that smaller team stay on track to their common goals. If it's an enterprise, now it's going to be talking about the entire firm, a whole company, a whole department, and how to interact with its environment. So you'll see software in both personal, work group, and enterprise. System software, three different types, basically. These are things that control the hardware, your operating systems, utility programs, and middleware, which we'll talk about briefly. Operating system, basically, they're the ones that control your hardware and the interface to the user. It can be both for special purpose, multiple computers, multiple users, single computer use, single user use. Gives you a ballpark some of the roles. I'm controlling the user interface, the applications, the stuff to the kernel and utilities, hardware drivers, hardware. So it covers a lot of different things. The kernel is the heart of the operating system. It is probably the most crucial part of the OS, and it ties everything else together. Now, operating systems, the types of functions they control common hardware, the user interface, input-output, degree of hardware dependence that manages the memory, the processes, the processing tasks, the network capabilities, files, printers, just tons of stuff. Things, common hardware functions, keyboards, retrieving data, printers, graphical user interfaces. From a hardware dependence, it's okay, how does an application program interface, to a particular configuration? Memory management, how's memory being managed? How fast? How's it organized? Is the memory physical? Is it virtual? Is it located someplace else? Does it handle, is it organized in one chunk, or is it several different groups of pages that you take a large block and break it into smaller segments, pages, and how's that managed access so that you have access to this memory in a timely fashion? Processing tasks, multi-user, multi-processing, tasking, multi-threading, real-time. All of these are used. Most of your systems today are multi-threading, which allows, I can take a single program, single task, a single instruction, and break it up into different pieces so that different processors can run at the same time and then bring it all back together. So you're going to see multi-processing, multitasking, multi-threading, even running on your laptop based on the application running. Is your system going to allow network, or is it going to be self-contained? The operating system's got to handle that. Access to resources, system resources, drivers, printers, login procedures. What kind of security are you going to do? File management. What files am I going to store? What am I not going to store? Personal computer. You got Microsoft, Apple, Linux. All of these are being used today. Personal computers, Chrome OS is another one that's being used. Now, stepping up from a personal to a work group, now it's just I handle a little bit more from a web server and management system. I use virtualization, so maybe I will have various operating systems run on a single server. I may have different tools that are being run. Advanced security, more robust. Linux and Unix can be used on several different. So you got Windows, Linux are probably the two. And from the internet standpoint, probably 97, 98% of your operating systems are in the Linux environment. Here you get a couple of different operating systems. You've got Red Hat. Some of you are probably taking Linux, so you're going to see Red Hat. And then Mac OS. And you see Mac OS is based on a Linux or an old Unix operating system. So you can see where that is a very important aspect. Some mainframes opportunity, if you run it that way, Linux, Hewlett-Packard, IBM. Now you got both embedded. Embedded is basically a computer system that's including a processor or put inside a particular machine to control another device. So you got a lot of different proprietary. Windows got an embedded one, but proprietary Linux ones are probably the biggest ones. Utility programs, these are just programs that help perform maintenance and correct problems with a system. There are several of them. I'm not going to go into all of them, but you can get which utilities are run. And when you boot up, you can find out which ones run at boot time. Middleware software allows different systems to communicate and exchange data. So just kind of keep that in mind. It's just kind of specialized software applications. This is what the user ends up seeing most of the time. The power of the computer is basically, if you had a chance of seeing what it enables, people, work groups to solve problems. So Excel, Word, PowerPoint, all of those are application to let people do things and solve problems. Now, some of them are proprietary, and some of them are off the shelf. Some are proprietary that says, hey, you need a special permission. A company owns it. You pay a fee. Some of it can be off the shelf. Some of the stuff is freeware that you can get that allows you to do what you need to do. Google has plenty of them up there. Google Docs and stuff that, even though it's not proprietary, you don't buy it, but it's an opportunity to get an application that you don't pay for. A little bit of differences between pros and cons of which one you want. But you can also have some software that says, hey, I want to give you software as a fee, as a service. So you're going to pay a fee to use my software. And you see a lot of this on the web developed, delivered business applications. Oracle, SAP, NetSuite, Salesforce, Google all have software that you can pay as a service. Personal applications, you've all used them. Microsoft Word, Excel, database, different things. Software suites, bundled packages, reduce the costs. So a lot of different ways of doing it. Here's some examples of different packages and suites that have come across through the year. Most of us are probably used to Microsoft Office, and the rest are kind of ones, and maybe some Google Docs, but the rest are probably harder that we don't play with too much. Tax time. Do your taxes, education purchases. So there are several different applications out there that you can get software from. You can run them on your mobile phone. You can run them on a PC. Now, there's also some that runs at companies that run from a business standpoint. Those are enterprise applications. These are software that the entire organization uses, and maybe SAP is one of the biggest things for managing employee information. So programming language, all these applications are written in a certain programming. There are definitely a set of keywords, commands, and things that the programmer can put in place to actually perform a set of tasks. And here's a list of different programs. Some of these you've probably just barely heard of, and some of these are probably closer to being put on the shelf, not be used again. But just give you an idea of what they are and some of the uses they were created for. Now, some of the issues in developing software is what? Software bugs, mistakes, things that either the designer didn't see, the programmer missed, testing didn't allow. things that didn't work in a software program is called a bug. Now, based on the software, you may have to worry about copyright and licensing fees. Open source software stuff that you can get free. Software upgrades, how many times have you say, hey, Microsoft say, hey, I got an update to download, reboot. So all of these things are issues that software developers and companies that either buy or make software need to deal with. Software bugs. We all know it's a defect. They keep it from doing it with what? How do I reduce that input? Make sure all your software is registered. Make sure you're not having some illegal software on your machine. That way, any new changes and bug fixes come in, you get the copy of them. Make sure you understand what are known problems. So you're not trying to get a program to do something that wasn't intended to, or they know about a problem. Maybe you want to look at some of the web pages that says, hey, what are the patches? What are the issues? Make sure you got the latest and greatest updates. And before you update a problem, make sure you can recreate the problem. Nothing else worse than you calling a help desk and say, well, I got a problem. Well, what is it? Well, I don't know. Sporadically, I get a problem. If you can't reproduce it, they can't fix it. So that's a big thing before you're doing this. So, and it's just making sure that you get the latest release. So some of these things are common sense and things we've kind of grown used to over time, but they just mentioned that something we need to make sure is made known publicly. Now here we got software products. Sometimes you give it unlimited uses, sometimes you pay for uses. So different products, different licenses. Sometimes you get a single user says, hey, I can install it on one or more used by one person. Once you do it to more people, you're violating copyright and licensing laws. So just pay attention to what software you've got loaded and what permissions you do or do not have. Open source software distributed typically for free, and in some cases you get the source code, or you can get access to the source code. And that way, if you want to, you can modify it. And part of the agreement is, hey, if you made a modified improvement to the software, you want to share it with the rest of the world also, and you're part of that open source development platform. So just something to keep in mind. I use a lot of open source software because I like it. It's free. What are you going to do? Upgrades. We all know the companies make changes, modifications to software. Keep those software up to date. Different companies upgrade different strategies. Just make sure you know that you get the latest and greatest software and you keep those upgrades up to date. Now, sometimes support of your software. Sometimes you can call an 800 number and it'll be a local company. Or if you buy specialized software, you can probably have one person in the tech support company you can call to get answers. Sometimes if you're calling a Microsoft application or a large app, manufacturer of software, they'll pay for global support because they want to make sure they're covered 24 hours, 7 days a week, which means I can't have somebody on the East Coast doing all that support work. It's going to float time zone to time zone, and you don't know who you're going to get to support your software, but it is still something that you need to. It's an issue that when you're getting software, how do you want that support done? So hopefully that was a quick and dirty overview of software and its different applications, and hopefully give you a little more insight into this chapter. Talk to you next week. Bye-bye.